The second part of chapter 6.1 is talking about continuous random variables. Anything that we can make a finite list of, we can create a probability distribution with that individual value and its probability. We can calculate its mean, we can calculate its standard deviation, but continuous random variables we treat differently. First, let's clarify the difference between discrete and continuous. I'm going to use shoes as an example. Shoe sizes are discrete. You're either a 7 or you're 7.5 or you're an 8 or an 8.5. We can make a list of all the possible shoe sizes that are made and the probability that someone is going to have that shoe size. Foot length, on the other hand, even though we normally talk about things in terms of a specific number like 23.5, we're going to get to the closest tenth of a centimeter. I really could measure down to an infinite number of decimal places. And because of that, if there's no way to make a specific finite list, and we're talking about measurement that we could go down to a very, 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 very precise measurement, we're going to call that a continuous random variable. And because of that, when we make a graphical representation of a continuous, of a discrete one, we're going to end up with bars or histograms that might possibly make a curve that is skewed or unimodal and symmetrical or skewed in another direction. And we can talk about that, its shape here. Oops, it's not, that's erasing it. Its shape. But when we talk about continuous, there is no probability for one particular shoe length. We'd have to look at intervals of shoe lengths, and here we are looking at a semi-normal curve. This particular thing, the work that we've done with normal curves, is the kind of work we're going to use when we're going to talk about the probability of it fitting between certain things. A continuous random variable, then we're going to be looking at density curves. And remember, I want to remind you that density curves always have a total, whether that density curve looks like a normal curve or whether it looks like a curve like that. We're going to have an area underneath it of 1, and it relates to the probabilities as well. So we're going to be looking at normal curves and reminding ourselves about normal curves. But remember that probabilities of discrete random variables are between 0 and 1. However, this is a weird thing. Continuous probability models assign a probability of 0 to 1, an individual outcome. There's no such thing as a probability of a 23.5. You're only going to be looking at the probabilities of intervals. Okay, and when we add up all of those probabilities and those intervals, it's going to equal a total of 1, just like when we do discrete random variables, all of the probabilities add up to 1. So this is basically just a review of the work we've done with normal probabilities. So there's most of the time we're going to be looking at intervals. When we did normal curves before, often it was the the probability that it's going to be a 65 or above or a 65 or below. And I want to remind you, like if it was, we were looking at 65, the area under the curve is always in using CDF norm or the table, it's always going to give you the area from that point down. And you would do 1 minus that to give you the area going forward. When we're talking about the interval between two things, then you're going to be going to deal with either using normal CDF and telling it what's your low and what's your high. We'll talk about that more in class, but
so there's 2 ways to find the probability within a range, an interval, on a normal curve, and that is to use a calculator, which I'll explain really quickly. But basically what you're doing is you're finding the z-score. I'm going to blow this up a little bit. We're going to find the z-score for 68, then you're going to find the probability for that using the table. You're going to take the z-score, go down to the table. You're going to do the same thing for 70, find the z-score, and then use the table to find the probability, then you're going to subtract them. That's basically the process. And we can use normal CDF to do that on the calculator, but I want to remind you how to do that. So if you are going to do it with the z-score method, make sure you show your work. Don't just give us numbers. So we're going to take the 68 and we're going to subtract it from the mean, the mu, divide it by the standard deviation. That gives you the z-score of 1.48. That's 1 and 1.48 standard deviations from the mean. And then 70 is 70 minus 64 divided by the standard deviation. That's 2.22 standard deviations from the mean. So remember, from -2 to +2 is 95% of the data. So a 2.22 is really high up there. To find the area of this space, or the probability of that interval of that continuous random variable, you're just going to subtract the probability for 2.22 and the probability of 1.48, because you basically are finding the probability of that minus the probability of that, giving you the space in between. Remember, on the z-table, the probabilities are always talking about the area below that boundary point. So if you have to find the area above, remember, you always have to go 1 minus. If you're going to use the normal CDF, you need to make sure you show what's going on. And so you tell the reader this stuff, which is the normal curve that we have, which is 64, 2.7, and then you go ahead and put the information that you actually put in your calculator. So your lower bound in this case is 68, the upper bound is 70, separated by commas, and then you're telling the computer what normal curve you have. You have a mean of 64 and a standard deviation of 2.7, and it will give you this number. It will calculate the z-scores for you, it will do the subtraction for you, it will give the area in between those two boundary points, and that's the probability that it's between a 68 and a 70-inch woman. So this focus was all about continuous random. Make sure you understand what a continuous versus a discrete random variable is, and then go back and practice your using the normal table and calculating z-scores, and or using the calculator, but being able to do those other things as well.